right?
Yes. Okay.
Okay.
Thank you everyone for joining us today. As you know, the topic of today's webinar is Inspiring and Developing Tomorrow's Circuit Stars. And today's webinar will be a little over an hour, and we'll hold a Q&A session after all of the presentations. We ask that everyone remains on mute, and unless you are a presenter, please turn your video off. This is just for bandwidth issues. And the webinar will be recorded today and posted on our YouTube channel. Please use the chat section on your dashboard to ask any questions, and make sure you select the Send to Everyone option. And I would now like to invite our SSCS Chapters Chair, Alvin, to give a few welcoming remarks and introduce our first speaker. And thank you.
Thanks, Abira. Hey, good morning, good afternoon, good evening, everyone. It's such a pleasure to have you here on a topic that is near and dear to many of us and myself, our society, obviously, recognizing that reaching out, encouraging folks to basically get into this profession that we've long enjoyed is something that's of critical importance. As I've basically mentioned before, it took a pandemic of a once-in-a-century proportion and an ensuing supply chain issue for the world to realize that we matter. Anyways, with that said, today's webinar, we have a very, very interesting lineup of speakers, and we'd like to end this or continue with hopefully a very, very lively interactive discussion with questions and so forth. So please participate there. We've got a few opening words from our society president, John Long, and then two presentations from two chapters, one in Serbia and one in Tunisia, who have been doing some extraordinarily interesting outreach and effective outreach to pre-college, both at the primary school as well as secondary school levels. And then we've got a special guest from my backyard, Tony Mauro, who's a high school teacher, a former very seasoned, experienced circuit designer who decided his second act would be to go back and inspire high school kids. Talk to us about his experiences, basically from the front line teaching high school kids how to inspire them and get them started, and what are the opportunities and challenges. And then we've got our very own Boris Murmann talking to us about this incredible open source initiative that is taking basically the planet by storm, and how SSCS and the PICO program that he has led can create opportunities, hoping to reach out to even high school kids, and then we'll have hopefully a good stage for a good lively exchange of Q&A. Okay, with that said, I'll keep my mouth quiet now. John, can you perhaps share a few words of inspiration for us, and we'll proceed. Thank you.
Okay, thank you, Alvin, and thanks for the invitation to come and open this session. Hello, everybody. I'm John Long, president of the Solid State Circuit Society for 2022-2023. And I thought I'd start with our standard SSCS slide about what we do for our members. Everybody knows, I think, on this webinar, what we try to do for everyone. Obviously, belonging to SSCS means that you have opportunities to network with your peers. People love to read our publications and get the information that they need to continue their career development. We also recognize achievement, and with awards, we have a number of international conferences that are well attended, either virtually or in person now. And we also offer student programs. But our student programs tend to be oriented towards people that already have advanced degrees. So somebody coming to join SSCS typically has a master's degree or a PhD or maybe beyond that. And they look to the society to provide them with career development opportunities for someone who's very well educated in the field already. But what we're talking about today is, people that are younger folks, maybe undergraduates, even high school students or below high school. And, those people, if they wanted to read the JSSC, would be pretty lost, I would imagine. They wouldn't be able to really get much out of a read through a paper. So I think what we have to do with these educational outreach things is create kind of a club SSCS. And by that, I mean, if you're in high school and you want to say, learn how to act, you join the drama club. If you want to play basketball, you join the basketball team. So with SSCS, we have to create some facility where someone coming from, almost no background in chip design could pick up enough to do something and get some fulfillment out of it. And I call that Club SSCS. Now, Alvin mentioned PICO, which is a fantastic program, and everybody wants a piece of PICO. I was just at a meeting last week where folks in the Circuits and Systems Society are keen to participate in PICO. I talked to a fellow who's leading IEEE's Africa initiative. He sees a lot of value in PICO for trying to develop in underdeveloped regions an enthusiasm for IEEE and what we do. So, PICO offers us an opportunity to dream big. If somebody really wants to make a chip and they want to get involved in chip design, now they don't have to just play around with 1 or 2 transistors on a bench like in a lab or maybe an operational amplifier. They could take a RISC-V core or maybe 2 or 3 and put them onto an IC and start putting them together with memory and other things and make their own processor. So we can encourage people to think a little bit larger than we have in the past in a lot of the projects that we want to offer to them. I think it's a good idea to be ambitious. And the last thing I wanted to mention was, folks that are going to be participating in these educational activities, we want to make sure they get rewarded. So there's a lot of commitment to do a project like we're going to be discussing. And when I first started doing circuit design, one of the greatest things about it was turning on that circuit for the first time and seeing it work. And that reward I still get today when I go into a lab with students and I turn on a chip and it works for the first time. It still is the same feeling. And I think we want people participating in our outreach programs and these educational things to get rewarded in the same way. So I think commitment and reward has to be a big part of what we do. Anyway, that's all I wanted to say as opening remarks. I'm really excited about what's going on here with this webinar. And I'd like to thank Alvin and Abira Altvater and Boris Murmann and all the other professionals and staff that are contributing to the webinar today. And I really look forward to what's going to come out of this. Enjoy the day. Alvin, back to you.
John, hey, thanks so much for your intro words. So let's proceed with our agenda. First off, we've got Sandra, who's the chair of the University of Nice. Sandra, thanks so much for your time to present for us. Look forward to hear about what exciting things that your chapter has done, which is really an inspiration to many of us. Thank you.
Thank you very much for the announcement. I must say that my colleagues and I are very proud that our chapter has been recognized as an example of good practice. So my name is Sandra Veljkovic, and I will present our University of Nice EDSSC student branch chapter. So first, I want to show you where are we in the world and in the IEEE hierarchy. So this is Serbia, and we are stationed in city called Niš. This is the 3rd biggest city in Serbia. And University of Niš is University of Niš EDSSC student branch chapter is a part of a joint chapter electron device solid state circuit.
Hey, Sandra, I'm sorry. I cannot see your slides. Can others see Sandra's slides?
Yes, we can see them.
Oh, really? Okay, it must be a networking issue on my side. Okay, my apologies.
Okay, everything is okay, yeah?
It's Joachim. I see the slides, who we are. That's the slide I see.
Yeah, that's the slide
bottom
now.
right.
Yep, that's what we're on.
Okay.
Okay.
Okay,
Thank you,
great.
Sandra.
Yeah.
You can-
Sorry about
Yeah.
that. Thanks.
Okay, great. It's important that everything is okay. Yeah. What I said, I think that okay, we are just part of ED SSC circuit chapter, and that chapter is a part of Serbia and Montenegro section. So moreover, the student branch chapter niche is also very active, and these two chapters and branch very often work together and organize different events and have great cooperation. So I will start with STEM projects. Last year we finished one project, and this year we got another STEM project. Here you can see the program activity of our first STEM project. Because of epidemiological situation, we had 10 online workshops and 10 live workshops. We worked with 6 schools in 3 different cities and around 120 students. After the project, we had about 15 papers for our final event, and that is the IEEE SSCS conference. Now we are preparing for another STEM project. That project is starting in September, and it will be another cycle of very intensive workshops, and we hope that it will be successful as the first one. Okay, here you can see, I hope, yeah, it's a video. So you can see our site dedicated to STEM project and how it looks like. After every meeting, every workshop, or every quiz, we prepare a report, and we always record all our online workshops. And last year, it was a great pleasure to have as a guest Eva Bonesh from the IEEE student branch from Slovenia, Olivier Leblanc from the IEEE student branch from Belgium, and the IEEE regional student representative, Theodoros Shatsinicolau. They were in niche for the student paper contest, but they found time to stay at our workshop and to be our guests. In the second part of the course, students worked in smaller groups so that we could follow everyone's progress. And as every year, at the end of a series of workshops, students present their practical realizations at the IEEE SSCS conference. We have excellent cooperation with our faculty, with our ministry, and with the Academy of Science and Arts, with different students' organizations, and of course with organizations which are promoting science. With their help, we can buy equipment for different types of workshops. So when students come to us, they spend time at the Student Creative Center, and this is the place which is presented here in pictures. So we have enough space for work, for developing, but also for entertainment. And here everything is dedicated to motivate students to continue working. But also we go to their schools and perform workshops there. So just in the past 2 months, we had many workshops. This is also a part of promotion of engineering among high school students to show them what it is like to make something that works. And also we want to encourage female students to study engineering if they like it. What they learn about. So workshops are dedicated to the basics of Arduino, ARM, Raspberry Pi, basic applications of electronic components, 3D printing. They learn about different and specific sensors. For example, here they learned about some sensors for radiation detection. Here, this workshop was held at Petnica Science Center, where talented students go and work in different areas of science. Our goal is to give them enough knowledge to encourage them to start participating and in workshops of this type, and also to practice something that's fun for them and interesting for them, because there is so much things that they could do. So the concept of each workshop is from idea to realization. We have a theoretical part for every workshop, just basic things. After that, they are given some mathematical problems to solve. Then we show some simulations in different simulators. And after all of that, students have the opportunity to do some practical tasks with protoboards, components, and sensors. Also, we have a few quizzes through the course. Students like challenges, so they get similar but not the same task as in the workshops. And after the quiz, of course, the best students always receive some symbolic prizes just to motivate them to work harder. At the end of the year, we meet again at our final event, the IEEE STEC conference. So this year it will be the Jubilar 15 conference, and participants from all workshops will present their projects at the conference, and they will write the paper and compete with their colleagues. Also, they will discuss about ideas, ambitions, exchanging experiences, and we always have many students who come to the conference for the first time. But there are also the students who are coming every year. And for many high school students, it was an event after which they decided to study at the Faculty of Electronic Engineering. And it's interesting that for many young assistants at our faculty, it was the first conference in which they participated in. So here you can see pictures from the opening ceremony, as well as from the whole of the faculty, where students come and bring their practical realizations. The best paper from the conference always go to student paper contest. And in 14 years, we had a finalist 3 times, 1 second and 1 third place. So we are very proud on the quality of our papers from the conference. In 2018, our chapter received the Chapter of the Year award, and this award really motivates us to work even more and harder every year. And that would be all that I prepared. Thank you very much.
Thanks so much, Sandra. That's fantastic work that your chapter has been doing. I guess we'll introduce our next speaker, Brahim. If you can please share your video and your slides, that'd be great. Sandra, please stop sharing your slides.
Yeah, I'm
Thanks.
trying. Yeah.
Okay, great. Brahim is sharing his content.
Okay, great.
Brahim, can you turn on your camera? Thanks so much, Sandra.
You're welcome. Thank you.
Brahim?
Yep, we can hear you. It's just a little low. Can you turn on your video?
I'm trying to do that.
Okay.
Well, at least you can hear me, right?
Yeah. Why don't we just proceed in the interest of time?
Yep.
Okay,
Thanks.
sure. So good afternoon, everybody. Thank you very much for this opportunity. And my name is Alvin was saying is Brahim Mezghani. I'm from Sfax, Tunisia, with the National Engineering School of Sfax. I'm a professor in the IEEE Department of Electrical Engineering. Today, I'm going to present the main junior activities of the Tunisia chapter, whose officers are listed in this slide. As you can see, we have a new representative, who we call the junior ambassador. So I'll start with why. Big why is it really important to organize junior events? John was saying very interesting things, but for a junior, I guess it's the interest. As I can see it, it is mainly to stimulate the interest of very young and pre-university students in general electrical engineering topics to start with, and whenever possible, details on design and technology of integrated circuits. It is also an opportunity for very young students to discover for the first time, of course, ICs and, if possible, related design and technologies, which we should put it in the behind most known applications among young generation to get their attention. It is finally, and I would say most importantly, to leave an unforgettable, an excellent impression, which should attract them as we are planting in them a seed of interest in microelectronics. As I can see it, seed of interest is the most important part that we have to take care of if we're going to talk with kids. So the first junior event, which was organized by our chapter, is the EN Junior 1.0. It is mainly consisted of the organization of a visit and a guided tour to discover various ongoing student activities in our institution. Our chapter junior ambassador, Sandra, invited 40 young students from 2 primary schools to participate in this event. Here are my dear students who belong to the Club of Electrical Engineers, or they call themselves CEE, have done a great job in all steps of organization and taking very good care of the young students. So thank you very much, my dear students. And actually, I would say, and I'm very confident of that, it was a wonderful experience for all of us. So here, as you can see, the visit started by welcoming the students, registration steps with the help of CE students. So you can see here the student is extremely happy with his badge. Visitors then and professors are waiting for the opening ceremony to start. And then after a short break that everybody did have, young students watched and listened very carefully to the engineering students, CE students, when they explained parts of their ongoing projects, which are mainly the homemade robots and electronic parts of a homemade car that the electrical engineering department is doing with the mechanical engineering department. So here we also offered medals to the young students. These were provided as a gift from our institution's director, Prof. Slim Abdelkafi, who I would like to thank very much for his continuous support. Now I'll switch and present our planned future events, which we shall call 2SCS Junior. We plan to organize the first edition of the 2SCS Junior on the day of August 13th. It will be integrated to a summer lead camp for high schoolers. The activities that we are planning include the study of the generally employed ICs in various electronics boards, which are used in very well-known applications, such as the IoT, smart houses, smart cities, as you can see here from a previous edition, from last year's edition of this very interesting lead camp event. The second edition of the 2SCS Junior event is planned to take place during next fall. It will be focused on pre-university laureate students. We shall identify and invite the first 5 students from the 6th year and 7th final high school year. They will be chosen from several high schools in the region and for best possible experience. We already planned on forming small groups of maybe 5 to 7 for parallel guided tours. As a final part of my presentation, I'd like to offer advice to volunteers on how to guarantee really the success of your junior event. I'll start by the required steps that should be followed by the organizing volunteer. You should start, of course, with your own institution. You should contact the director to ask for permission to organize, use infrastructure, in my case, my institution's bus to bring the young students. Also, directors of the electrical engineering department, eventually other departments, if you plan on visiting them, in order to use their labs, infrastructure, ongoing projects for applications, experiments, which can be and should be actually of a great interest to the young students. On top of that, you should check with engineering students, clubs, including the IEEE ones, if you have them. These can not only help in the organization, but also with presenting their ongoing and finished projects. At the primary school or high school, you should contact the director to ask for permission from him or her, and also from corresponding local authorities. Then you should get in contact with the teachers who will help to identify the young student participants based on clear conditions. This is an important part. How will you choose those students? Which should be previously discussed and fixed in a chapter meeting. A very important step is also, of course, to discuss and choose a, let's say, good day, where teachers, professors from both sides should be, of course, available. And then depending on each one's situation, you should prepare. And I should say we already planning maybe a month ago for the fall event. Well in advance that you're planning, what you're planning on showing and giving to students to make it most memorable visits of their lives. So you try to do that. You should try to do that so that they will not forget that. Examples include items, gifts. I don't know. What we're also planning are 3D printed transistors, ICs with logos and stuff like that. What you should always here keep in mind that you should adapt to whatever conditions you have in your own institution so that you guarantee, okay, the sought young students' interest. So the interest comes here. As I can see it, it's the probably most important part that you should think about. This can be easily attained, of course, through the planned activities and applications which are to be experienced during their visit. It should be clear to you, okay, that organizing a junior event is different, I would say very different, from what you will be doing with normal events with students from the university, I mean. I would add that our society and the IEEE directives and even bylaws should also be adapted if juniors are a shared interest and priority. To finish last slide, to conclude, I'd like to talk about a general important fact, which probably nobody would see it, but I'm experiencing that, and I think it's very important, which says that any volunteering activity will deliver a personal satisfaction. Now, everybody knows, okay, that volunteering is giving without waiting to get something back. Okay, you should be fully convinced that someday, and I would say someday, you never know when, you'll get back much more than you have been giving, because that has been always the case, okay? When dealing with junior folks, you should know and feel deep inside of you that the volunteering work you're doing impacts not only you, professional career, but certainly I would say more importantly, your own personal life. If you have this conviction, then without even thinking, okay, your words will have a huge impact on the young students who will like you and even love you from the first meeting. Obviously, this would help a lot in getting their full attention, which will therefore increase the impact of whatever you're planning on doing with them and for them. This concludes the presentation, and thank you very much for your interest and for listening.
Yep. Thanks so much,
Alvin?
Brahim. Yeah, thank you. Really appreciate your presentation and all the great things that your chapter is doing. Okay,
Thank you.
if you can stop sharing, let's move on to our next presenter. So next on our agenda is Tony Mauro, who is a high school teacher and at Canyon Crest Academy here in San Diego. Tony, can you share your slides?
Yeah, I'm still seeing that Brahim needs to stop sharing.
Yeah, I don't know.
Can you stop sharing?
Stop sharing. That's it. Okay.
Okay,
Okay,
here we go.
Okay, thank you. Yeah, and yeah, Tony, thanks for doing this. You know, it really gives us great perspective to hear from someone in the front line. You know, kind of doing exactly what we are all pontificating of how to do this right. So really appreciate your time to do this.
Okay, well, hopefully you can see my slides. I think I see them up.
Yeah, I see them. Thank you.
All right, well, thank you, Alvin and Abira, for inviting me. I really appreciate you guys including me on this talk. I'm super inspired by what I've seen and heard so far from Sandra and Brahim, especially Sandra's, you know, inspiring projects and things that she's working on, and Brahim, the how-to on the junior events. It's super important. Moreover, the opening remarks from John Long regarding the club SSCS, I'm super excited about that. I want to know a lot more about that, because that's something I'm really wanting to try to pull into my classrooms, and I'll explain that as I go through my slides. My background is in electrical engineering. I have kind of a windy road in my career. I worked for many years at a San Diego, so Southern California based telecommunication company called Qualcomm as a design engineer. I started teaching in 2008 at the high school level, where I do computer science and engineering circuit design type classes. But because my background is in EE, I sort of have a soft spot for the electronic circuit design parts. And this is where I feel like we have the most challenge, and this is why I'm so excited about being invited to this talk. Yeah, so we'll just keep going. When Alvin came to me with this kind of challenge, he asked me, okay, well, you know, as he mentioned, you know, frontline worker, you know, in the high school and dealing with the kids every day, what are some of the challenges? And really one of the main motivators for me to jump into the teaching profession from industry was because I was seeing that we were having a hard time finding quality engineers and computer scientists, and I thought, well, you know, maybe I can do my part and try to get more kids interested in this. And so I think that's the kind of the main motivator in trying to jump into this field. So the challenge really is to how to fill that front end of that pipeline. And so I'm kind of going to talk about two different areas. Really in the engagement part, so engaging students in electronics courses, and that's what I have direct knowledge of. I've been doing it for several years now, and so I can share what my views are on that. And then on the other side, the interactions, and so this is where the other guests have talked about and how they make the connections. And so I'll tell you what I think from a teacher's perspective and what I see. I have this kind of busy looking diagram below, but this one I'll come back to talk about it more with respect to how those interactions can occur between, say, a middle and a high school, a post-secondary university college type environment, and then in industry. And I have some experience to share with that as we go on. What I wanted to talk about first was as I teach my classes, along as a teacher, you learn what works and what doesn't work, and so you sort of refine your curriculum as you go on. I teach an electronic circuit design course in digital electronics, and I always give a kind of an end of the course satisfaction survey to the kids. These classes are usually pretty popular and filled. In our classes, we have like 35 to 40 students every semester or every half year. I break the course into two sections. One is in analog circuit design and the other one's in digital logic design. And I find that the students are always more engaged and interested in the digital logic design. And I'll talk a little bit about why I think that is. But I have some, there's some, kind of busy looking bar graphs over here that basically show, hey, when we do analog circuit design and we're doing, basic network analysis or filter type operations, analog filters, and then applications where we use semiconductor components and or passive components. How does that work with the students? And so you can see that, I have some things about, what was their initial interest when they came in? What did they really know about the field? How difficult did they think it was? Where did they see a possible real world connection? Because that's important when the kids see that, oh, yeah, I see how this connects to my, my life as a teenager. That does spark some interest. Hands-on projects, super important. I'll talk about that later. And then their overall satisfaction. And so I always kind of want to see where they, where they lie on this. And so you can see kind of a description of what the kind of things I cover in these two fields. This is where I would want to get some feedback from industry folks and, collaborators on, these are some cool areas that you might want to consider bringing into your classroom to engage the students. Because again, the overall goal is to get more of these guys and gals into this field and and being productive and pursuing it. What I try to do is provide connections to the market. So one of the things that I have kind of in my back pocket is my industry experience. I think it's fairly unique, and I try to tap on it as much as I can in trying to show, okay, well, here's where you would use this. And so I try to do that with everything that I teach. So it's not so theoretical, because that's when you start to lose the kids. Even though it's important, when you spend too much time digging into the the theoretical background of things, then they tend to kind of drift off. And so you really want to grab them. And so on the analog side, we, as I mentioned earlier, filters, conversions, signal amplification and conditioning, and then we talk about logic gates, where we're sort of bridging from an analog to a digital world. In the digital side, we'll get into CPU pipelines, so we get into that level of sophistication. I'm not, I don't view digital electronics as working with microcomputers like Arduinos or Raspberry Pis. I view it as what is the design of the Arduino and the Raspberry Pi, and so we get into kind of that part of it as opposed to just let's just code it up, because that to me is more of on the computer science side. And so we talk about basic things like flip-flops and gates and how do you build a counter circuit and what's an ALU and that kind of stuff. Definitely a must-have. Supplement with hands-on projects. I have I'm fortunate enough to have a large space with lab benches and equipment that the students can use, and so we build stuff. So whether it be small scale integrated circuit boards where they're actually, we got it in a spring-loaded protoboard and they're wiring it up, or an MSI type components where a little bit more functionality built into the ICs, or going into FPGA-based platforms where we get into schematic capture-based circuit design, but then also going into VLSI type applications, or at least high-level description language stuff where we're targeting the FPGAs. And so it's really important to have those kind of connections and flexibility to pursue many different areas that can try to make that connection with the students to some sort of outside world that they can, little light bulb will go off and say, I see where that might be used. So that's the engagement part. Second part, what I want to talk about is how to do some interactions, and this is where, again, I scratch my head on this because in the States and in California and just in general, there's a push which to an area called career technical education, CTE. It used to be known as, in the old days, as vocational education. Where students would learn, they would learn some sort of trade or some skill, and then they could go out into the workforce and they get some apprenticeships, and then they could move their way in. Now they call it work-based learning experiences, and they call the programs now CTE. I think it's the kids are always looking for an advantage to differentiate themselves when they're going to go on to college. And so they look for these work-based learning experiences, internships, to provide that extra kind of bullet point on their applications and their resumes. And so it's a ripe area. They really look for that. I've implemented some within my classroom where we have connections with industry through internships of a program I call a flipped internship, and I'll talk about that in just a second. But in general, when I pull this diagram back up that I put together, that I try to make it simplified in that the stuff on the top really is sort of established interactions that we see, at least in the States. We see this as, okay, well, the universities, they will provide what the competency requirements, and they have summer programs, and then they'll talk down to the middle, mostly to the high schools, and universities will have programs that typically the high schoolers will engage with. And then the industry then will have skill set, they'll tell the universities what skill sets they need, and they'll do some research collaborations with the universities. And so there's sort of a two-way interaction there. That's pretty well established. On the bottom side, where you have the red dotted line, this is where it's a little bit more sparse, and it's sort of ad hoc. It's depends on who the person is and what the area is, the region is, and how engaged the institutions are. You may see that there's research opportunities and work-based learning opportunities between a university and a high school or a middle school, or interactions with industry to the schools. And again, we saw some examples of how this is done. But again, it's not something that is an established club thing that like John was talking about earlier. So if I were to say, hey, what do I need, right? So all of the people who are out in the audience that are in industry and are saying, okay, well, I want to, how can I contribute, or how can I give back, and what can I do to help get these kids interested in this area? There's a couple things that I'll point out. This is a thing that's in the United States. We have this thing called advanced placement courses at the high school. They're AP. They're termed AP and advanced placement for college credit. We have those in computer science, and right now we do not have anything in engineering, especially in any of the engineering fields. They have math APs and physics APs, and they say, okay, I guess they got that covered. But they don't have anything specific to any of the engineering fields, like electronic circuit design. I mean, there could easily be a EE based AP course, I think, that students would want to take and would be interested in. And so we don't know if there's a demand at this point, but I believe there would be, just in my own experience with working with students. Certifications is another thing that students are really, again, see it as a value add. And so I basically said, well, where would the target live? Who would we target if we were to say, hey, this is what I would like to have. Who could help us out with this? Well, the colleges there's an organization called the College Board that authorizes AP courses and exams and things. And so that would come from the university level. That's what the post-secondary would be. And then an industry would be like, okay, well, can we get some teacher training to bring in these types of projects and the technology to the classroom to help train teachers, where many of them are in industry and it's hard to get them to come into the school systems, and so maybe do some training there. And then salary surveys, industry rock stars. Again, if you tell the kids, you know, they all know who Mark Zuckerberg is, they all know who Bill Gates is in the CS side, but do they know the top rock stars in IC design that have come out, in the last 50 years or so? Tools and equipment, can always use that. Tools and equipment for electronic circuit designs are expensive, so getting that into a classroom is paramount. If you can't do that and you can't provide those hands-on projects for the kids, then it just becomes a theoretical thing, and the kids again won't get too engaged. They really, my experience is that they really like to build stuff, and so getting equipment in that would help with that is pretty important. And then finally, this is the one that I'll talk more about in this item down here in the lower right, called the flipped internship. This is what I've worked on in the last several years in my classroom, but it really comes back down to providing these work-based learning opportunities for the kids in industry, and then doing research-based internships maybe at the post-secondary level. And so what is that, what do we want to do there? We're trying to get the kids workforce ready and give them training, and whether or not they say, okay, well, after this, I've got enough training that I could be, say, an entry-level engineering technician or something like that. Or they say, hey, look, I could work part-time while I'm going to school, or I get a nice bullet point on my resume that I can offer to the universities when I'm applying to their programs. So having those types of opportunities for kids is pretty important. Having competitions, I think this is something that everybody on the panel has so far alluded to or outright discussed, was having these types of events and clubs and things like that. There's a robotics club in the States called First Tech, and it's a very large national organization that does a good job of getting students together and getting competitions. And so it's kind of like, the sports, on the sports side of things, analogous to the tech side. So having those types of things where you could put that together, say in the EE world, that would be good. And then research opportunities. Again, if you can have that with an industry or a university partner, that's very valuable to the students. Traditional internship challenges, usually what happens is you have to the kid will go to the facility, and then they do the work for whoever their mentor is. I found a lot of pushback on that when I tried to do that with my high school students, because of work permits and labor laws, having facility resource allocation issues, where, okay, like, where are we going to put these kids when they come in? Who's going to manage them? We're going to have to watch them. And then what about insurance? And so they really, kind of stepped back when I was really pushing to try to get my kids placed in some of these areas. And so what I thought was, okay, well, let me just flip it then. Let me just say, I'm going to do everything in the classroom. The school districts like it because the school districts have a challenge with it for the students to go to a facility, just because of, again, they want in the States, again, if the kid is in the classroom, they get funding, and comes down to some money issues there, and insurance and transportation issues. And so they like the idea of having the kids in the classroom. So again, what I had mentioned earlier was that, okay, well, I said, well, let me try to flip this thing. Let me try to set up an internship where, because we have this advanced technology like we're doing right now, where we're doing these these webinars with people all over the world. Why can't we do these things sort of online and long term? And it really helped with when we shut down for COVID. We were still going full speed because we were used to that type of arrangement. It's going to provide the opportunities for the students for supervision and specific practice, where the teacher, myself, is in the room as the manager, and we have mentors that are offline that don't have to worry about all of the things that I mentioned earlier. And so the difference between the traditional is in green, and then the split model is in blue, where instead of being off campus, we're on. We're applying the stuff in the classroom, and as long as we have the facilities available, then we should be able to be productive and successful in the kind of projects that we're working on. This is just a couple shots of my room where I have different groups that are working on different projects. We have on the left-hand side, we have this is our interaction with our mentor. So we have all of our students gathered around, and we have our mentor that's talking to them and going through, you know, whatever design and schedule things that we're working on. And so it works out pretty well. This is I'll go through this really quickly. Is just how we do this kind of thing in the classroom. We have to coordinate. So I spend, frankly, a lot of time working with mentors and potential project collaborators on defining the project and figuring out what the scope is. And for me, it's like, well, what can the kids do? What are they? What's their competency level, and what are they capable of doing from a project standpoint? That's where I can help. Then we kick it off. We assign it. Meanwhile, I'm teaching the kids while we're going through the class. What are some of the key, you know, areas of design development? What's agile? What's Scrum? How do you actually build a project from concept all the way to delivery? Once we do that, we're assigning projects to the students, and then we start rolling with it. And so we'll do weekly updates with our mentors. Sometimes they come into the campus. Sometimes we just do a video call. And we're working through a project. And so it's just, you know, same like you would in industry. You work through your project, you have periodic feedback, you work towards a schedule, and then you work to get some acceptance testing on it. And so it's been pretty successful. There's a couple shots here where we've got some students that do outreach events. We get experiences with our industry partners. They bring our students in for some like full, you know, traditional summer internships. As a result, we go to their facility and we give talks to the industry, you know, as an industry kind of meet and greet, and we pitch the projects, and we get, they get rated on them and get some rewards and things like that. And so it actually works out really well, and it's been pretty successful. The industry likes it as for the purposes that I mentioned earlier, and we found that this is a good way. And so if there's an opportunity that you have as an industry professional to reach out to your high school and kind of implement a program like this, I'm more than happy to help and try to facilitate things like that, just based on my own experience. All right, and with that, Alvin and Abira, I will say thank you very much, and I appreciate all your time in listening to my talk.
Hey, thanks, Tony. That was fantastic. Covered a lot of ground, and I'm sure folks are having all sorts of questions here. So let's go with the final presentation here. Boris. Great, thanks so much. Can you turn your camera on? I'm not sure.
Yeah, I'm trying. Let's see.
Okay.
Can you see me now?
Thanks, and Boris, I was gonna say to you and Tony, thanks so much for waking up so early to do this.
Oh, this is not early. This is everyday life, during COVID, with Europeans and Asians interacting with us, right? So
sure. Okay, thanks.
All right. Well, thank you, Alvin, for giving me a few minutes to show people what's going on with PICO. Maybe some of you haven't seen what we're doing. For some of you, this is just an update. Just a quick note, I am now the chair of a newly established committee that I will talk about, which is called Technical Committee and Open Source Ecosystem, that basically is owning this program now. And I will show you a little bit about who's involved and what our charter is. But first, let's get to to the main point. And obviously, this has been eloquently discussed in all the previous presentations. Students, they like to build, they like to hack nowadays, they like to work together globally in real time. And if we want to stand a chance to sort of bring IC design to these people, we have to make it way more accessible, inclusive, and open. And so I think we've been struggling over the years to figure out how to do this. But luckily, there was a big bang in about the end of 2020 when the first foundry, SkyWater Technologies, decided to open source a real process design kit that is actually usable for manufacturable chips, and you can actually do real tape outs. So what this means is that you and I can download a real PDK from the internet, we can design a chip together, and we can actually get it taped out in various ways. So we saw that within the SSCS Directions Committee, and we jumped on this immediately and said we ought to leverage this to do something and to develop a program. And this is really what PICO is about, platform for IC design outreach. It's meant to be a long-term effort that uses these open source capabilities. But the first thing we did is essentially launch a chipathon. And here you see a snapshot of what we did in 2021. The idea was basically to say, okay, world, IC design world, or enthusiasts, or people who are interested, please send us your ideas on what you would like to design, and we will support the tape out, and we will mentor you during the design process. So we received 61 proposals from around the world. We selected 18 teams, and 11 actually took their designs to tape out. You see here a map of participation. It's not yet the way we want it to be, but we had at least some good response from South America. Pakistan came out to be very strong in their submissions. We also had some places in Asia, India, Egypt, and so on. And so we ended up meeting every week from August to November. These were very lively meetups. And this is really the first time also in my career, I've been doing this stuff for 30 years, that I could talk to other people about real design and real issues in process design kits and layouts and so on, because finally these NDAs are gone and they're allowing us to do things that were not possible before. We tried to, of course, get some of these students into the SSCS. We offered memberships. The Pakistan team decided to launch an SSCS student branch. So there were a lot of good, interesting things going on, networking, kind of tapping into, anyway, this very quickly growing open source ecosystem. Here's a quick view on what people managed to design. So clearly none of these designs would be at the sort of leading edge of what you will see at the ISSCC, but people did actually finish quite a few impressive designs and got them taped out. So here you see we funded six Carawell frames, as they're called, on these eFabless Chip Ignite programs that tape out into SkyWater, and this is a 130 nanometer process, by the way. Again, what's different from your usual tape out is that everything is shared on GitHub, and it can actually be reused and inspected by anybody. So you see the collaboration. Many teams were able to share silicon area, and they designed, some people designed relatively simple things, band gap references, but then there were quite a few sophisticated circuits as well, like a sonar processing unit. There was a neural network accelerator, and so on. So you can check out all these projects if you want to take a look. So we were very pleased by this, and I realized actually even before we did the Chipathon, there's a lot of work to do and there's a lot of opportunities. So I wanted to have a dedicated committee within the SSCS that owns this, and we call it Technical Committee and Open Source Ecosystem. So I assembled people who are familiar with the open source movement, sort of an international group, some of which actually have participated in last year's Chipathon as students like Rana, or as faculty like Durga. So this group is meeting every month, and we're trying to figure out what to do next and how do we improve the chipathon and what other things can we do to help the ecosystem. So specifically, our charter is to own this chipathon for the time being. We are kind of the engagement point with the broader open source community, which now, by the way, has about 3,000 members or so. We can count this by Slack channel membership. There are some industry consortia emerging, like the CHIPS Alliance out of the Linux Foundation. We're talking to them. They may also provide funding down the road for our activities. So this is a good trend that industry is seeing what we're doing and they want to support us. Another important aspect is publication venues. All these students, undergraduates, graduates, they want to publish their designs, and it'll be difficult for many of them to get into top-tier conferences, but there ought to be a venue where they can still go and maybe even present the open source design aspect of this. You know, how did I manage to do X, Y, and Z with the constraints I had? Another important point is tools and education infrastructure. So the tools in this open source ecosystems are still crummy, to say it politely. They still need a lot of work. They're not easy to use. And so we're hoping to continue to help with this. So one thing that already my committee did, Harald Prettel, one of the committee members, he created a very nice Docker container that has all the open source tools pre-installed. So now within half an hour or so, you can get all these tools on your Linux box or your Windows machine or your Apple box, and start playing and start designing ICs. The other bottleneck, of course, is that right now we can't have enough people. You know, if you want to get engaged in any of this, please let me know. We need more people to contribute, to help as volunteers, you know, contribute to tools, education, and so on, making little video snippets about how to run something, how to design something. We could use a lot of this. There's almost endless need there. So we are now in the second chipathon. So we had a deadline on May 1 for people to submit their proposals. There was a little more self-selection this year. We realized, so we got 55 submissions, so not quite as many as last year, but the quality was much, much higher. And the level of sophistication of the designs was much, much higher. So we selected 22 teams out of this. And one thing that's worth noting, I didn't make a map here. I'm not showing a map, that almost half of these are from Pakistan this year, the selected teams. So that has really become a hotspot for this open source IC design. They have some very strong local mentorship, and that seems to make all the difference in terms of participation. So it's great that I can speak here, because I think the chapters could potentially make a big difference here also in helping with local mentorship and encouraging students to participate this and submit your designs. Here's, by the way, a look at what the students get to design with. So there's a 10 square millimeter of white space. We want to share that between different designs. And down here, there's a little service processor and actually a built-in logic analyzer that makes it really straightforward, actually, to design arbitrarily digital chips. For analog, it's a little more manual, as always, but that's why we're there to help. All right, so this is all ongoing. And so what I want to end with is some pointers for people who want to read more. So we have a program overview page that has kind of a summary of all the different things we've done and what's going on right now. I try to keep that up to date with the latest events. My committee has created a resource page, so you can go to this webpage and kind of learn, you know, how do I get started with these tools? Where do I go? How can I download the software? How can I read about the PDK? So this is supposed to be the one-stop shop for, you know, how do I get started with this whole open source stuff? And I think it's getting some attention. This is only a couple of months old, this page. And then finally, as I said, we're always looking for volunteers, and the formal way to go about it is to go here and sign up. We have an official SSCS sign up on the webpage. You could, of course, also just shoot me an email, and that's, of course, the easiest way to do it. With that, again, I want to thank you for providing me this opportunity. Happy to discuss further. Thank you.
Hey, thanks so much, Boris. Keep up this amazing work that your new drug cartel has been inspiring. Yeah. I did want to just thank all the speakers. This has just been a phenomenal amount of effort and time. Really appreciate what you're doing for this effort. So I guess let's kick off with Q&A. I don't think there's any restrictions for people to actually unmute themselves and ask questions. If I may start, one question. This is for Tony. Tony, when can we expect your students to be submitting to the PICO program and the Chipathon?
Well, Alvin, thanks for that. I was taking furious notes when Boris was talking and some screenshots of the link. So I will be on that site. And yeah, there's some local help, including yourself, maybe that we can organize to try to submit something. So yeah, I definitely look forward to getting involved in that.
Awesome. Yeah, I did want to say, so Abira, if it's okay, I guess, if it's okay with everyone, let's post the PDFs of the slides online so that folks have access to all this material, this great material that's been just presented. Abira, that's okay, right? Everyone's
Yes.
okay here? Okay, great. Okay, yeah. So yeah, let's open this up. Like I say, there's no need for me to moderate the questions. You can unmute yourself and ask some questions, and let's have this. For folks who just presented, please turn your cameras on. Let's have a lively discussion.
So Alvin, I see a few questions for me or also remarks from Sergio and others. Maybe we can go through these first.
Sure, absolutely, Boris. Go ahead.
So yeah, Sergio, you ask about conversations with other societies. So to be honest, so far I haven't really discussed with anybody. We are so busy with what we're doing, and I was expecting that they may reach out to us at some point. I think there is value in combining forces, right, and joining with CAS or EDS. But so far, yeah, I think I haven't made an effort to reach out, and I don't think they have. So that's the status on that. I don't know. Do you have any specific ideas, Sergio, on what we should do?
I think that CAS society would be very welcoming. I have a few friends who sit in the board of CAS society, and they would be very welcome to see this Chipathon, let's say, engaging across societies and across regions and being more, let's say, supported. I recall EDS last year, they supported a competition, IC competition in Region 9, which is my region, South America, and Latin America, actually. Yeah. And and that was supported, they did a tapeout through IMEC, 180 nanometers, something like that. But we had, it didn't have 10 millimeters square. Every group got about less than 3 square millimeters, which is good for many universities group. Even in Brazil, we teamed up with several universities to use that opportunity. So EDS, I think, is open, and CAS especially needs to be reached out. CAS put an educational program for Africa, and that was led by Silva Martinez from Texas A&M. So there are educational activities that would have a boost if they could see an opportunity to tape out and to propose meaningful designs for the PICO program. I love the PICO program. I thank you very much, Boris. You've been a champion of that, and you've been a great let's say, person to lead this. I thank South Civil Society for doing that. But IEEE, that has to be supported at the IEEE level, as any K-12 program also, right? So my suggestion would be to reach out to CAS and EDS first. Maybe the smaller society like the packaging and manufacturing, the PTM, something like that. Mm-hmm. Thanks, Boris.
Yep. Have a question. This is coming from Sudeep. Sudeep, do you want to ask your question, or should I just go ahead and read it? Can SSCS run a seminar or tutorial on open source mixed signal tools? An outcome would be 1, uptake of those tools for teaching circuit courses, 2, volunteers who will help improve these tools.
Yeah, great request. I will take this to my committee. I definitely have people who could give such a seminar, because there are a lot of people within our circles who are using these tools, who are very good at it. I just have to twist their arms because it will take time to prepare. But we can do this, and it may be very much needed. You know, talking about the tools, I think, you know, as much as we want to ramp this up as fast as possible and go exponential, I think the tools are still a major bottleneck. If you were to try it yourself, the tools are relatively crummy, like I said. And if you were to scale this up too fast, there may be students or participants who get frustrated about the tools and drop the ball. So I actually want the tools to clean up a little bit more, and also the whole design flow. As an example, I showed you this chip frame that eFabless provides. It's mostly good for digital people now. When you do sophisticated analog stuff, it's a little weird to deal with this digital frame. And so I have now talked eFabless into making an analog frame for us. And that'll actually be available starting November for our tape out. And so all these things are kind of slowly developing. And as we figure this out, I think sort of next year and the year after, these things will become way more scalable as we, you know, kind of figure out the details and smoothen everything. But in the meantime, I definitely agreed. This seminar on open source tools, that would be awesome. Yeah, I would attend it.
We need to invest in clone technology, Boris.
I know.
Yeah.
Well, I mean, I would not be the right guy to teach it, but we have, let's say, Mehdi from Michigan or somebody like this. I mean, there are people who are breathing this open source stuff. We can get them in and do this. Maybe I have to combine 2 or 3 people, then they will do it. If everyone does 20 minutes, it becomes more doable.
Yeah, something to add to that, Boris. So in silicon photonics, we've done it very successfully. We started off with open source tools and started giving tutorials and lectures, and then it actually caught up, and a lot of people in the community started to add to the tools, and so maybe we can bring CMOS open source tools back, mixed signal tools back, and eFabless would definitely guide and lead this effort, but it will, yeah, having more people will definitely help. And then for our classes, some of the courses we teach, we don't really need to tape out till the very end, so we could make use of some of these open source tools and start putting it in our curriculum.
Yes, absolutely, fully agree. Yep. Yep.
Thanks, Satip. So to a related question, Stefano Petri asked, you know, what kind of infrastructure do you need for PICO to accelerate even more designs? Do you need ESD, I/O, logic, and how can we coordinate such that it can get done for the next round of submissions? And of course, how can we help from the industry side?
Yeah, I think, you know, the good news is we have, I mean, all these things, ESD, I/O, logic, all of this is basically taken care of. So like I said, the main bottleneck is really the tools and the tool flows. Basically, what happens is this. So this technology is actually a Cypress technology. And Cypress had kind of a well-crafted PDK targeting commercial tools, right? So Cadence PDK. And that was ported over by a bunch of Google people into the open source domain once it was released. Now that port was not perfect. And there still exist quite a few bugs that need to be worked out and all this. And this is really, in my mind, the bottleneck. So it's not that we don't have ESD or digital libraries or any of this. Actually, everything is there. In fact, the technology is quite fancy. There's even photodiodes, there's RM cells, there's Sonos devices, there's all kinds of weird stuff available. But it's not well documented, or the tool flow is not perfectly set up for it. And all of these things are being worked out right now. But definitely, you know, the good thing about open source is if someone who is knowledgeable about these things, they can drop in pull requests and actually fix the PDK. And you know, this is the nice thing. And this is happening. It's just taking time.
Got it. If there are other chapters joining that have been doing pre-college activities, you know, please, we'd love to hear from you as well. So I have a question, I guess, is more directed to Tony and Brahim and then Sandra. When I was back in grad school, I remember giving tours sponsored by the Women of Society of Women Engineers to a bunch of like 9-10-year-old kids of the clean room that we had back at Stanford. And I remember being completely shocked by a student. I would ask, well, why do we need a clean room to be very clean? And I swear, this little girl raised her hand and she said, to improve yield so we can make more money. And that just about shocked me. You know, I have no, at least I should have no presumptions about what kids are capable of learning at these days. And so from your experience, right, I mean, you know, given where they are in high school or elementary or primary school, you know, what are these kids capable of absorbing? Are we being presumptuous as to, you know, them not being capable of learning new material, you know, or is this a matter of just inspiring the interest and going from there? So I'll pick on Tony.
Okay, yeah. So I'll jump. So I think Alvin, I think it almost was kind of a leading question. Definitely, we can inspire these kids, right? I mean, they're very, at least the ones that I've been exposed to are very capable. I do a yearly kind of outreach to the community that showcases kind of like a science fair type thing, showcases the projects that the kids have been working on. And every year, the industry people are wowed. They at the end of the event, they're telling me, I had no idea these kids could do the type of designs that they're doing, you know, in your classes. And so I think that whole idea of, you know, you inspire them and then you get them connected with people from industry that can excite them and show them, you know, here, you can do it, and you know, and give them really cool things to work on is really beneficial, and it really does help them kind of prosper and grow. So I think that, yeah, definitely they're capable. I do, you know, in reference to your previous question, I do, to me, I do believe that a group with the kids that I work with are capable of submitting a design, you know, proposal to the PICO project. I think, you know, maybe they won't, you know, get chosen for it, but they're definitely, just from the projects that I saw, there's definitely capability there for the groups that I've seen. So I think, you know, just in my little, you know, view of the world, I'm sure, you know, everywhere there's these types of kids that are available. So I think definitely is something that if we can provide tools and the mentorship can be done, definitely can be done.
Sandra, Brahim, I mean, have you been increasingly shocked and surprised?
I can say from my part, really, when we saw when we see how they are enthusiastic when they are working, and I think that they just need little bit more support because they don't have enough time in school to work. So practical that professors don't have time to work with every kid particular. But if we give them just support or just a sentence, yeah, you can do it, or just to fix a small problem they find somewhere in their design, yeah, they can do a lot of things. And I must say that they don't have that barrier to try to find help like some older people, like they don't want to find help from anyone else to try to find some support. Kids do, and when we give them, they're so motivated to work even more, to work even harder than did before. So yeah, we are amazed when we see how good they are and how much they could work.
Thank you. Thank you.
Same here. It's really incredible to see all this work. What I wanted also to point out is what Tony has been saying and repeating the same words that I was focusing on is interest. The moment that you go into, as I can see it, I don't know, the moment that you go into really technical stuff, they will kind of leave you, something like that. So you should always keep on getting their interest from the very beginning to the end by the application. So if you keep the application something which is they know, they like, they have been listening to that, they're interested to that, then you will always keep their attention, and that would be easier to help them with. Well, I wouldn't say the projects like the PICO. I don't know if in high school we would be able to do that, but from the parts that Tony was showing, I think that would be very interesting in the high school level.
Sounds good. Well, in the interest of time, we're a little bit over. I do want to, on behalf of the society, Abira and I, thanks so much, to John, who had to leave earlier, but Boris, Sandra, Brahim, and our guest speaker, our guest of honor, Tony, for joining us, sharing all this inspiration. There's a clear call to action here, and I guess it's up to us to go chase it, right? And with that said, thanks so much for everyone's effort. Continue to with all your fantastic work, and I'm assuming I'm going to just boldly ask folks to reach out to the speakers today if you have questions. Let's move the needle in the right direction. Okay. So with that said, thanks again for your time, and I look forward to everyone to stay safe and healthy, and look forward to see you all in person in the not so distant future. Okay. Take care, everyone.
Thank you.
Thank you.
Thank you. Thank you very much.
Thanks a lot.
Bye-bye.
Thanks a lot, folks. Good to see you. Thanks, Alvin.
Thanks, Alvin and Abira.
I was going to make a quick comment. I'm just so glad I graduated from high school when I did, because given how hard, how high the bar is now, I have no hope.
Thanks, folks.